Okay, so we're going to have a look at another question from the topic of electromagnetism. We are told a positive charge particle is moving right through an up electric field. The electric and magnetic forces exactly balance. In what direction does the magnetic field point? Okay, so we're going to draw a diagram for this. Before we start drawing our magnetic fields, we're going to draw our electric field. So this is an up electric field, so this is the same as having a positive charge plate on the bottom, and we have a negative charge plate up the top. We're going to use this when we introduce our particle to work out what's happening based on this field and then what needs to happen for the magnetic field. So this is an up field, an up electric field, so it does this. A positive charge particle is moving right through an up electric field. Okay, so there's some particle here. It has charge which is greater than 0. The electric and magnetic forces exactly balance. In what direction does the magnetic field point? Alright, well the charge particle based on the electric field wants to move up. This is the force due to the electric field because the positive charge wants to get to the negatives, which are up the top. So this means that the force due to the magnetic field, FB, must point down. So we have a velocity vector that points to the right. This is the velocity of the particle. We have a force due to the magnetic field that points down. Now you can use a version of your right hand rule to do this. Normally your thumb points in the direction of the force, your index finger points in the direction of the velocity, and then your middle finger, when extended, when they're all at right angles, points in the direction of the field. So we have your thumb points down, your index finger points to the right. This means your middle finger points up. So in this case, we are going to have a magnetic field which is pointing out of the page. So we denote a magnetic field pointing up with little circles with dots in them. The reason we use circles with dots in them for up is if you think about an arrow sort of looks something like this. If you look at an arrow heading towards you, it's a circle with a dot in it. So this is moving this way. If you look at an arrow from behind, it's a cross because you're sort of seeing the fletching forming a cross, assuming that the fletching forms a cross. So this field is pointing up / out of page, and this is towards us, as opposed to away from us. Now, in what direction does the magnetic field point? It's possible that it's not at a perfect right angle because we don't actually know the strength of the field. So we know that the force due to the field, F of B, is the charge of the particle times the velocity times the field times sine of the angle between them. Depending on the field strength and the theta, B times sine of theta could be a fixed value for varying values of B and varying values of theta, right? So we don't know that it's necessarily pointing directly out of the page towards us. It could be pointing out of the page towards us, but at a slight tilt, right? It could be tilted slightly and still allow the particle to travel this way. But the answer to this question that we want is out of the page and towards us, with the caveat that there could be a slight tilt there, given that B times sine of theta can be a constant for variable B's and variable thetas.